Hey everybody, this video is for Friday, October 8th. Hopefully you came in and started your do now. What's the weather like today? What was the weather like on Labor Day, if you remember? And what do you think the weather will be like this weekend? Pop those answers into your discussion in Schoology. It'll be right over here. So those little people in my house that were sick have now gotten me sick. So here we are. Hopefully it won't be like this for too long, but you might have to watch some videos of me for a few days. It's okay, we're gonna get through it, but I really need you to be responsible for your own learning, especially because the end of the 9 weeks is coming, and I need you to be ready, and I need you to know what your grades were. So remember, you can always check your grades in Schoology. I will still be updating them. Your tab over here says grades. Check it at any time. All right. So today you are going to do the do now as usual and then click this page at the top of the Schoology materials page that says October 8th instructions for class. The first thing I want you to do is click this video and watch it. It is a famous scientist, Neil deGrasse Tyson, explaining the difference between climate and weather. Next, you are going to open your digital notebook, which will be in upcoming assignments, and open it to slide 11. Okay, your digital notebook will be right over here on this upcoming assignments page at the bottom. Click Unit 3, Digital Notebook. Once you get it open, I need you to go to slide 11. As usual, I have a daily slideshow that if we were in class, I would be presenting those slides to you, and then you would be filling in your digital notebook. You are going to have a link to my daily slideshow that you can reference because there's a little bit more detail in it than there is in your digital notebook. But to help you, I'm going to do the notes from the digital notebook so that you know exactly what you're supposed to drag and put into each blank. Okay, so follow along. No excuses to not finish these slides in your digital notebook. Okay, I should, though, tell you our learning target for the day. I will define the key vocabulary words and symbols for weather. So by the time you finish class today, I want you to be able to define an air mass, define and describe high pressure, define and describe low pressure, define and describe cold fronts, define and describe warm fronts. Okay? After that video, hopefully you know the difference between weather and climate. Weather is current weather conditions, climate is long-term, the patterns in an area. Okay, this is where we are going to jump over to your digital notebook. Okay, so we have weather. Describes the current conditions of the atmosphere. Climate is the long-term weather patterns of an area. There are 4 factors that affect weather. One of them is heat. We already know a lot about that from our convection current experience with hot and cold water. Heat is transferred from the sun. Air pressure is a measure of force with which the air molecules are pushing on a surface. Imagine blowing up a balloon, okay? The air molecules inside of the balloon, as you push, have a certain amount of pressure as your air comes out and goes into the balloon. The amount of pressure that those molecules are pushing on the outside of the balloon with, that's air pressure. Winds, all of you have experienced wind outside. Winds are caused by differences in air pressure, and they are the movement of air from high to low pressure. Last of our 4 factors that affect weather is humidity. So moisture or humidity is the amount of water vapor in the air. I think lots of you knew that. I also think some of you are going to find my typos in this slide. Thank you. I know. Okay, moving on to slide 12 in your digital notebook. We're going to start with air masses. An air mass is a large body of air that has similar temperature, moisture or humidity, and air pressure throughout the whole air mass. Air masses are classified by 2 characteristics, temperature and moisture. So over here on this US map, These little tiny circles are supposed to represent different air masses. Okay, we're going to label them with what type of air mass they are after I explain how an air mass gets its name. Okay, so an air mass gets its moisture and temperature. Where's moisture? There it is. Gets its moisture and temperature characteristics from the area over which it forms. Meaning, if it's dry, it's forming on top of land. If it's humid, it's forming over water, usually the ocean. Okay, so look at these two air masses. This one is forming over Canada. If we were in class, I would quiz you and see who knew that. So would that be dry or moist? Yeah, it's dry. Okay, and then up north of us in Canada, is that typically cooler or warmer weather than us? Yeah, it's cool. So this would be a cool and dry air mass. I am going to let you figure out this one. Okay? It is forming over the Gulf of Mexico. That's part of the ocean. So think about if that's going to be moist or dry, and then think about if it's going to be hot or cold. Put the label right there. Okay, there are two different types of pressure. I'm sure that you have seen them on weather maps before, okay? The first is high pressure. So you're going to drag the word high right here. The way that we remember high pressure is to always say that high pressure is happy weather. Yay, okay? Both of those start with H. It's a really easy way to remember it. High pressure is happy weather. Low pressure is the other one. So that one goes over here. And our memory device for this is that low pressure is lousy weather. We don't like it. It's drizzly, it's yucky, nobody likes it. Okay, with high pressure, because it's happy weather, usually everything looks dry. We have, and it also often happens after a cold front. Okay, not during the cold front. No, things are a little crazy during the cold front. After the cold front has passed, we often will have an area of high pressure with clear, dry skies. Think about a winter morning after a thunderstorm rolled through the next day. Okay, low pressure is basically the opposite. We can often get some storms with low pressure. It is humid and kind of gross outside. And we typically have warm, yucky air. Okay? So high pressure, happy weather. Low pressure, lousy weather. And I do want to show you my slide for pressures because it gives you a tiny bit more detail. Okay? We talked about the density of molecules when we did the lab thing. So another thing I need you to know about these two different pressures is that high pressure is dominated by the air, the molecules sinking, dropping down lower towards the ground, okay? Which leaves clear skies up above us. That's why we get really sunny weather. Low pressure, on the other hand, is dominated by that low pressure. The molecules are not packed together, so they are more free. They are less dense. They are more free to rise above, and when they rise above, they make clouds. So low pressure, lousy weather is because those molecules are moving up into the atmosphere right above us and making clouds. Okay, back to your digital notebook. Great job. Okay, from pressures, we're going to fronts. So a front is a boundary. Wait a second. That should be front. A front is the area where two air masses meet. Because the cold air is denser, it sinks down beneath the warm air. Fronts are always named for the air that is behind the front. That can be tricky. When you see a front on a map, it's moving one direction, okay? So say my arm is the front. If it's a cold front, all the cold air is back here, is behind the front. The temperatures usually change right when it hits, and then they can keep dropping after that. Okay, a cold weather front is a boundary between a cold air mass and a warmer air mass. Cold weather fronts usually move from the northwest, think like Washington State or Seattle, north of California, okay? Northwest to southeast. Okay, so this is my mouse is going to move. If this was a map, it would be moving from the top left corner down to the bottom right. Okay. It is when cold, dense air pushes warm air up out of the way. So a cold air mass just comes in like a bulldozer. Bam! And it pushes all the warm stuff up higher out of the way. Cold fronts move very quickly. Again, that's why they're like a bulldozer, okay? They come in. And they bring short periods of heavy rain, thunderstorms, or snow. Okay, caveat for snow. It cannot snow when it's like 80 degrees outside. So make sure you check the temperature on your map. It's got to be like 34 degrees or less for it to snow. The lower temperatures are always behind the front. Okay, I'm going to let you be a little creative here. I need you to draw or find on your friend Google a picture of a cold front and insert it here. They look like this one. Cold front, like icicles sticking out. Those triangles are like icicles. Okay. Also, this is a really great picture with the cold air behind our cold front, and it's pushing the warm air up and out of the way. Okay, warm fronts. A warm weather front is a region where a warm air mass is replacing a cold air mass. Warm fronts usually move opposite, southwest to northeast. So think like Arizona up to the northeast, like New York. Okay, so they're going to start down here on the bottom left of a map and move slowly this way. Most of the time. Not always, but most of the time. Warm fronts move slowly. Okay, remember cold fronts were like bulldozers. They came in real fast. Warm fronts move slowly. So that's why they bring many days of steady precipitation. Think of kind of a warm spring weekend where it just kind of rains the whole weekend. That's probably a warm front coming in. Okay. After the front passes, weather conditions are warm and clear. So not during the front. During the front, we're getting some rain. After it's passed, things are going to get clear. Higher temperatures are behind the front. Okay, again, right here, you are going to use your friend Google or your little drawing tool up here, Scribble, and draw a warm front. It looks like this one. Red one with half circles on it. Okay, and here's another picture. They move slower because they can't just bulldoze that air up and out of the way. Warm air is less dense, so it has to slowly push the cold air over. Okay, I'm going to run out of time, so I might have to start another one. But quickly, a stationary front is where a